Hi, this is Steve, and I'm going to give you an overview for your physiology data. What we're going to do is we're going to do a statistical analysis to see if there's any difference between the two different protocols, those protocols being an incremental and then the second one being something called a decremental protocol. So let's have a go. This is the data that Ryan's given me, and it's a quickie overview. It gives you all the anthropometrical data at the beginning, age, mass, height of the subjects, and then all the other data that were measured in there, from VO2 absolutes all the way down to blood lactate levels. 15 subjects done it, and what Ryan or someone else has done is put in the mean in there. This will help you with a quick overview analysis to see if there are any significant if there are any differences. So for example, for VO2 absolute, the incremental got 4.14 litres per minute, and then for the decremental is 4.02. So there is a little difference, but the big question is there a statistical difference? So of course what we'll have to do is churn out some stats and do those amazing t-tests. Now what we can do is we can upload the appropriate data pack from Excel so we can do statistical analysis, or if you have the capacity you can actually use SPSS to do it. So it's all in there, all titled up, and one thing I've also done is just make sure that the data is in the right format. So for example, the IDs are classed as nominals and all the rest are measurements, or in other words are scales. So there we are. So the first step, of course, whenever you're doing any statistical analysis, is to work out whether the data is normal or not. If it is normal, we'll do one set of tests, and if it is not normal, then we'll have to use a different set of means testing. So what we can do is I'll click on Analyze, and I'll click on Descriptive Statistics. I'll go into Explore for this one, because you can do a few other tests on it. And all I'm going to do is I'm going to do a blanket test for everything in there. So I'll click on everything, stick it in, and I'll just check, see that that's okay. With the plots, that's okay. I'm going to click on normality plots with test. That will give us a bit of more statistical analysis, and I think you guys prefer histograms because then you can see visually whether it is bell-shaped or not, whether it's skewed, kurtotic, or so on. So I'll put those options in as well. So that's all happy and hunky-dory. I'll click on OK, and voila, there we have it. We have all the data. So the first table here, what that will identify is where your data is that are there any errors or anything missing, and there's lots of 15s here, so that was all 15 subjects, got all the data in there, that's all happy. The next thing here are the descriptives, so it will tell you the means for them all, and you can have a quick ganders to see if there are any differences and all that. Like, it'll show you a measurement of skewness and kurtosis, and that's all brilliant. But let's cut to the chase. What you want to know is the data normal? And I think the best thing to do is have a look at this data here. There's two tests of normality. One is the KS test, Kolmogorov-Smirnov, and then the Shapiro-Wilk test. For most of the tests that you'll ever do with sports science, it's always wise to use the Shapiro-Wilk. And the magic number we're looking for is 0.05. If these values are above 0.05, we can assume that the data is normal. If it is beneath 0.05, then we can assume that the data is not normal. So for example, this one here, VO2 AB difference is not normal, and the VO2 relative difference is also not normal. So all the rest we can class as normal. But luckily, those two are the diffs, and when we're going to be looking at if there is any significant difference between incremental and decremental, we're not going to be using the diffs. We'll just compare inc to dec, and that's it. So we can ignore that one and ignore the other diff that is not normal, and so we can assume that the data we're going to analyze is normal. Interestingly, if you look at the age, then the histogram is quite flat, and also you look at the minimum and the maximum ages there, 19.5 to 22.5, it's quite narrow. So the question is the sample that has been tested, does that best represent the whole population of the world? And the answer, of course, is no, because not everyone in the world is between 19 and 22. So you have to maybe look at the title of your project. Instead of saying a comparison of two tests for the general population, is more to do with a comparison of the two tests for a student population. And actually, if you look at the body mass as well of these people, once again, it is slightly skewed to the heavier side, and to me that's a sign of the student sample that you've actually sampled are undergraduate students on a sports course. They kind of fit this profile quite well. So maybe it is changing the title to a comparison of the two tests for sports students. If you do that, everything is all happy and hunky-dory. Anyway, that's a side thing, so let's get on with the main test. The main test is looking to see if there's any difference between the incremental and the decremental test. So we've now identified that the data is normal. So what we're going to use is we're going to use a paired samples t-tests. That works with the normal population when your data is normal, and so that's what we'll use. So I'll click on that, and what I'll start doing is highlighting the two pairs. So we've got VO2 incremental and decremental as one comparative pair, and so on. So VO2, VE, what else is there? RER, HR, and BLA. Okay, that's all done. Just check the options. Yep, we're going to go for the 5% confidence level, or 95%, and we'll click on OK. So first of all, in the paired sample statistics, what you get are the means and the standard deviation. So looking at the means for VO2, pretty similar, VO2 pretty similar, there's a slight difference on VE, pretty similar on RER, HR, so just by eyesight you can say there doesn't seem to be too much of a difference. Interestingly, paired sample correlations, VO2 scores quite highly, and so does, well, both VO2s, the absolute and the relative, so they look okay. Which means there's a nice range in there instead of being very narrow. We'll go back to that narrow bit in a little bit. But the important thing, is there a difference between the two? Well, looking at the significant values here, once again, what we're looking for is a value that is below 0.05. If it is below 0.05, we can say there is a significant difference. So is there a significant difference between VO2? Not really. Is there a significance between the heart rate and the blood lactates? Nah, not really. If we look at VE and RER, then there is a significant difference. So there you go. In your reports you can identify that there is a significant difference between the rate of ventilation and RERs, but everything else is not so.